All right, guys, welcome back. Today we're going to, in this lecture, we're going to look at how you implement a queue with an array. So if we want to implement a queue like we did a stack, one end would be fixed at index 0. So this was nice for a stack because we always add and removed from one end of a stack, right? So we added to the end, so the stack would grow. We started at 0, and then the stack would grow up, and then we would decrement or increment, and it would always be from the far away side, right? The larger index side. So the problem with the queue, though, is that it operates at both ends. So if let's say we implement this in some naive way, and we said, okay, I'm gonna add. When I add, I'm gonna add to. Let's say I'm in this example here, so I'm at 4. 4 is the rear. So I'm gonna add to element 4, and then when I take away from element, I'm gonna take away from element 0 when I dequeue, right? I'm gonna enqueue. I'm gonna add to 4. When I dequeue, I'm gonna add 0. Then I'm gonna shift everything down after I dequeue, right? So what would be the order of operations for the dequeue in that case? So because I have to, if I've got n elements in the array and I take one out, I'm going to have to shift n-1 elements. Shifting n-1 elements is going to take me n-1 operations, which means it's an order n operation, okay? And again, we said that what we prefer is that it be order 1. Order n isn't terrible, but why have order n when you can have order 1? Order 1 is much faster than order n. We want it to be much nicer. So we don't want to have to do that shifting, but we still want to implement with an array. So the question is, how do we do this efficiently without shifting? All right, so a better way to look at this is to treat the array as circular. So a circular array is a regular array that's treated as if it loops back onto itself. So that is, the last index is thought to precede index 0. So you're used to your arrays being 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then that's the end. But with a circular array, we would say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the 11th, 12th element would be element 0 again. So we think of it as looping back onto itself. It's an odd way to think about it, but we'll show you how to implement this. It's actually pretty easy to implement it. So we're going to use two integers to keep track of where the front and rear of the queue are at any given time. All right, so this is what a circular array is going to look like. So again, we're going to start at 0. We're going to go around to n, and then the n plus first one is going to be, well, element index n plus 1 is actually the n plus second, but element index n plus 1 is going to be 0 again, okay? And so the things that we're going to keep in our queue, where the start and the stop of the queue are in this circular array, is going to shift. So if you dequeue, so let's say the rear of it is at 7, the front of it is at 3. If we add one in, then the new rear is going to be 8. If we dequeue one, then the new front is going to be 4, right? So the thing that we're doing here is it's going to sort of shift around. So the weird thing with this is going to be when it shifts around, when it moves around like this, at some point the elements of the array are going to straddle the end of the array, right? So the front and the rear, so normally if you look at this, you would expect that the front would be smaller than the rear, right? The front number should be smaller than the rear. But in fact, that doesn't have to be the case. If we loop around, once this thing loops around that circle, the front could be larger than the rear, if that makes sense to everybody. So we have to think about this, how we implement this. So here is an example after we've enqueued AH. So we have front 0, rear 8, and count 8. So after A and D have been dequeued, so we're going to dequeue A through D. Now our front is going to be 4. It's going to be that E. Our rear is still that at H. So now we're going to enqueue IJKL. So we're going to enqueue IJKL, and at this point we're going to wrap around, right? We're going to wrap around in that circular array, and we're going to enqueue at 0 and 1. K and L are going to be at 0 and 1. And now the rear is 2, the front is 4. It looks a little odd. We'll look at how this actually gets implemented. All right. So the way that we implement a queue with an array, we're going to have both the front and rear index values that are incremented, and they're going to wrap around to 0 when necessary. All right. So the trick to this, the key to this is this percent. So this percent is the modulus operator. All right. You remember the modulus operator? I don't know if you remember the modulus operator. If you don't remember the modulus operator, the way it works is it returns the remainder of a division. Okay. So if I say 5 mod 3, that's 2, because 1 times 3 is 3 plus 2 is 5, right? So the modulus operator goes from 0. So mod n goes from 0 to n minus 1, right? Because once we get to n, then it'll divide in evenly again, and it'll go back to 0, right? The remainder will be 0. Make sense? So let's look at 3 again. So 0 mod 3, 0, 0 mod 1, or 1 mod 3 is 1. 2 mod 3 is 2, because it's 3 times 0 plus 2, right? And then 3 mod 3 is 0 again, because 3 times 1 is 3, and the remainder is 0. So it's the remainder of an integer division. It's the integer remainder of an integer division, right? That's the modulus operator. So it's gonna wrap around always, and the value of that mod operator is gonna change between 0 and n minus 1 if it's mod m. So if we mod by the queue length, we're going to go from 0 to queue length minus 1, which is the length of our array, right? So queue.length is the length of our array. Our indexes are going to go from 0 to n minus 1. And if we go above n minus 1, then we're going to wrap back around to 0. That makes sense? All right. You have to think about this. Write some of these numbers down. If you've forgotten this, I'm sure you've seen this. If you haven't seen it, you're seeing it now. All right. So here is our circular array queue. It implements the queue ADT. We're going to start with the default capacity of 100. We're going to have our int front, rear, our count. We're going to have our queue, which is our array. We're going to have another constructor lets us set the initial capacity. Still going to set everything to 0. The initial values of everything is going to be 0, pretty much like everything was null in the last one, and it's going to make one of an array of a different size, right? So we're going to create the empty queue. This is the default constructor that creates the empty queue using the default capacity. So here we're going to call in queue. So if size equals queue length, we're going to expand the capacity. So we're going to make this thing larger. If we're trying to add more, so you have to think about exactly what that means. It's a little weird, but we're going to make it larger. So queue of rear equals element. So we're going to add the element to the rear element. We're going to add the element to the rear position in the array, right? And then we're going to array rear equals rear plus 1 mod queue length. So we're going to increment the rear, and then we're going to mod. So if rear plus 1 is less than queue length, this is just going to return rear plus 1. But if rear plus 1 is equal to the queue length, it's going to return 0. Okay? So hopefully that makes sense. If rear plus 1 is less than the queue length, strictly less than the queue length, it's going to return rear plus 1. If it's greater than the queue length, it's going to return, or equal to the queue length, it's going to return 0. Can't ever be greater than the queue length, right? Because that wouldn't work. There's no way they can ever do that. We're only incrementing by 1 every time. So we're going to increment the count, which is the number of things that are in there. So the rear index, we're going to push forward, and then we're going to wrap it around to the beginning of the queue again if we go up past the end of the array. Okay? Expand capacity is going to do something pretty much like the other one. We're going to double the size, and then we're going to we have to recalculate front because because of the way the queue works, right? We have to recalculate the front because we're modding by something different. So the acceptable indexes are going to be different. You have to think about this, how it's going to shift. But basically, it's not going to shift. If you multiply it by 2, you can probably do a better job than what they're doing here because you're always incrementing it in the same amount. You're doubling it every time. So there's a relationship between... Anyway, don't worry about this. Just have a look at this. We're basically shifting everything around and we're recalculating the front and the rear, okay? So the rear is still always going to be the count because we just made it larger. And then the front is going to be front plus 1 minus q. So we're going to recalculate the front in the new index or based on the new q length, okay? So you might have to think about this for a little bit, how this works, but it should be, it's a little odd, but it does work, all right? And the reason this is weird is, again, because remember, you're wrapping things around. If you increase the length of it, maybe you don't have to wrap it around anymore, right? Does that make sense? It's a little weird, but... All right, so the DQ is going to basically do the opposite. If it's empty, it's going to throw an exception. We're going to look at the front element. We're going to get the result from the front element. We're going to set the front element equal to null. And then we're going to increment the front and then mod by the queue length, again, because it's going to wrap around. And then we're going to decrement the count, return the result. So the queue works basically exactly like you'd think for the array. Again, you're going to have to sit here with some examples maybe and go through it if it's not quite clear to you. Put some things in there. The way that I would approach this is I would write out a little array for myself with some things in it, and then look at the different cases. Look at the case where the front wraps around, where the front's not in the same place, or maybe we've decremented. Maybe the front is at the end, then we've decremented it back around to the 0th element. Does that make sense? So the front can be the last element, and then when we decrement it, when we increment it, it's gonna go around back to the 0th element, right? There's some weird cases here dealing with the wraparound, and the way to do that is you just need to sit down with a piece of paper and put some elements in there, and then walk yourself through the code. Okay, what would this look like? Okay, what are the indexes? What are the indexes going to look like after I run this code? And then just sit there and take a look at it, right? To get this in your head, how this works exactly. All right, so that's the end of the lecture. Thanks everyone.